All right, guys, let's jump into number 6. So number 6, which side looks to be more complex? I'd say the left side for sure. I also don't like the way that my copy turned out. That looks like a stupid mess here. So what do we think here? Could I rewrite tangent, my denominator, as sine over cosine? Like this. Similarly, could I rewrite cotangent as cosine over sine? Keep it up here, like that. Okay, so I think we know where we're going with this. We have fractions, we're going to have to combine them, which means we're going to have to get common denominators, but boy, is that going to get messy the way we have these denominators. So instead, we're going to ask that question that we ask, well, all the time. When you're dividing fractions, what do you really do? I'm going to multiply by the reciprocal. So what I'm really going to do is I'm going to take sine x, not divide by sine over cosine, but instead multiply that times cosine over sine. Similarly, on the other side, we're going to take cosine x. So I'm going to not divide by cosine over sine, but multiply by sine over cosine. And as you can see now, we have a whole lot of cancellations that are going to be taking place. So what that leaves me with, this is all going to clean up to be cosine x plus sine x. What was my target? Oh, there it is. Okay. So guys, like I said, are there other ways, other avenues that we could have taken to get? Absolutely, but I do think that this was the most direct. Okay? How do we feel about number 6? Okay? All right, on to number 7 then. Number 7. Again, this I know is throwing some people off slightly. The whole, do I go after the left side or the right side? And once again, I would encourage you to go after the left side because of the fact that it's a binomial. This may be the exact same one that we did on the bookwork. I'm not certain. It looks familiar. Maybe I'm just remembering doing this earlier today. So on the left side, could we rewrite tangent as sine over cosine? And similar to that, could we rewrite cotangent as cosine over sine? Everybody's in agreement? So if we're going to pull this off, we have to get common denominators. So I'm going to multiply top and bottom on the left side by sine x, top and bottom on the right side by cosine x. So what that's going to give us on the left side, when I multiply top and bottom times sine, that's going to give us sine squared x over sine x cosine x. Plus, on the right side, what's that going to give us, please?
Cosine squared x over sine x.
Sine x cosine x, good. And we have it. Okay, we have the common denominator of sine x cosine x. Sine x cosine x. Okay, similarly, now we can bring the numerators together. Sine squared plus cosine squared. And hopefully gigantic alarms are going off in your brain right now. Anytime we see sine squared plus cosine squared, what does that mean? That's the identity that tells us that we have 1 over, again, that common denominator, sine x, cosine x. Now remember the target. The target was secant x, cosecant x. Do we have the ability to split this? That's my question. When I say split, I mean, could we rewrite this as 1 over sine x times 1 over cosine x? Sure. Well, what is 1 over sine x, please? It's going to be cosecant x times 1 over cosine x is secant x. Now, as we look back to the original, is that exactly the original? No, the order's off. Now, are they equivalent to each other? Absolutely. But, yes, we do have to rewrite this in the correct order. Secant x, cosecant x. Again, because if your argument is, oh, come on, you know that that's the same, guys, we could have said that about this set. That's equivalent to my right side. It doesn't look anywhere near, but it's close, or it's equivalent. So again, that close isn't going to count here. Does that make sense? We need to get it to the point where it looks exactly the same. All right, guys, number 8, last one. This is most definitely a problem that on the surface might look a little bit more complicated. Are we all in agreement, by the way? Left side is where we're going to start. Okay. Now, my worry is that we might have some people that jump straight in here and we just start foiling things out. And I've honestly never tried this problem that way. I'm sure you could do it. I'm positive, in fact, that you could do it. But we could be a lot more efficient here. What is 1 minus sine squared? 1 minus sine squared, that's just simply cosine squared. Okay, similar to that. What's 1 plus tangent squared? That's just simply secant squared. All right, now, if I'm trying to get this to equal 1, that means that I better have some cancellations taking place. So it doesn't matter which direction, if I change cosine back in terms of secant or if I change secant in terms of cosine. I just weirdly would guess that people would prefer to leave this in terms of cosine and to change secant back to 1 over cosine squared. Okay? And if we see that we're doing this, and I multiply these, do we agree cosine squared over cosine squared is going to equal 1? So like I said, as long as we see the identities, this problem was simple. Could we have been successful by foiling out the left side? I'm sure. I've never tried it that way because that seems like really overdoing the problem. Okay? All right, so guys, I am going to circle back. I know that the bell's going to ring here in a couple minutes. A couple minutes, actually. I'm going to circle back and hit number 4. I'm going to put that on the video. But I would like for you guys to finish number 4. And then your homework assignment is going to be coming out right now. Let me stop this video. All right, so circling back, let's take a look at number 4. Number 4, as we talked about in class, again, this one was just going to take a little bit longer. First, to admit, there are multiple ways to go about this problem and every other one for that matter, but I think that it is clear to see that the left side is definitely where we want to target. So first thing that I'm noticing on the left side is that we have a fraction plus another fraction, and it's equal to a monomial. So again, all indications would point to the fact that we're going to not just want, but need to condense this via adding our fractions. So if what I have, again, just copying what we have, is tangent theta over 1 plus secant theta plus 1 plus secant theta over tangent theta. Just like every other problem, if our task, our duty is to combine these fractions via addition, I have to have common denominator. So that means that I'm going to multiply by tangent theta. If we do that in the denominator, we also have to match that, do that in the numerator. So that's what's happening on the left side. On the right side, we're actually going to multiply by the entirety of 1 plus secant theta. So if we do that on the bottom, we've got to match do that at the top. So, again, this takes care of our common denominators, but it also creates a mess up in our numerators. So what that's going to do for us, like I said before, tangent times tangent, that's going to give us tangent squared theta over, we've got tangent theta times 1 plus secant theta. Over here, we've got, okay, this is going to be a lot more fun. We actually get to square this out. So, again, not square, excuse me, we get to FOIL this out. So foiling the numerator, we have a binomial times the binomial. So I'm going to multiply first times first. 1 times 1 is 1. Outside, 1 times secant theta is secant theta. Inside, secant theta times 1 is also secant theta. And then our last term, secant times secant, is secant squared theta. All right, this is all over. Once again, tangent theta times 1 plus secant. So especially on the right side, we have some consolidation to think of. So if we're looking at, excuse me, again, the simple part here, if there's a simple part, is the common denominator of tangent theta times 1 plus secant theta. The not so simple part is the combination of my numerator. So we've got tangent theta plus, all right, well, we have 1. Secant times secant, plus secant is going to give me 2 secant theta plus secant squared theta. And once again, I know that I've said this so many times in class and in other places, that there are a lot of different ways that we could approach this problem. So many different ways that we could approach this problem. But right now, now one of the things that I'm noticing is the tangent squared plus 1, which happens to be one of my identities. So in place of tangent squared plus 1 up in the numerator, I'm going to rewrite that as, well, that's just simply secant squared theta. The rest of this is going to stay the same. Plus, again, we have 2 secant theta plus secant squared theta, all of which is over tangent theta times 1 plus secant theta. Now, we don't want to lose sight of the fact that my target, what I'm trying to get to, is 2 cosecant theta. That's what we're trying to get to over here on this right side. So, we still have some work to do. All right, so combining like terms. Again, in the numerator, we do have like terms with secant squared, secant squared. So I could rewrite my numerator as 2 secant theta plus 2 secant squared theta, all over this common denominator, yet again, of tangent theta times 1 plus secant theta. Again, keeping on with this, thinking about what we could factor out of the numerator. Again, factoring out of the numerator, I can factor out a 2 secant theta. What that's going to leave me with in the interior is now 1 plus secant theta. Remember what this is over. Tangent theta times 1 plus secant theta. Again, you may have thought, where is this guy going? It's taking us on a crazy route. It's because I was trying to get these 1 plus secant thetas to cancel, and we're finally there. Again, so we are currently looking at 2 secant theta over tangent theta. Remember what that target was. We're trying to make this into 2 cosecant theta. That's the goal. All right. So really, at any time, we probably could have pulled this off. I know that tangent theta, if I were just simply looking to change this back to sines and cosines, tangent's going to be sine over cosine. And again, at any time, we could have made this move. But if we think about when you divide fractions, what you're really doing is multiplying by the reciprocal. So that means that my numerator of 2 secant theta, what I'm doing is I'm multiplying that times the reciprocal of sine over cosine. So multiplying that times the reciprocal, cosine over sine. And like I said, we're just inching closer and closer. That's going to put me, if we're in the business of changing some terms up, that's going to put me at, well, secant is merely 1 over cosine times cosine all over sine, like this. And in the numerator, 1 over cosine and cosine, they take care of one another. That leaves me with 2 over sine theta, at which point we could rewrite as 2 times 1 over sine theta. And finally, we're there because 1 over sine theta is cosecant of theta. So there is a very good chance, once again, that you're following along with this and saying, yeah, but why didn't you do it this way? I'll be the first to admit that there were probably many other options as far as how we went there. Again, this is the way that my brain was thinking through this one here and now. So again, we were able to obtain 2 cosecant, and that was the target. So here we are. All right, so guys, please make sure that that you're putting in the time, you're putting in the effort with these trig identities. Again, you're doing great. Should you have any questions, please come see me. But again, like we talked about in class, the best way to improve with really so many things, but especially these trig identities, it is to practice. Again, we've got to get to the point to where we just see problem after problem after problem, and you're going to very, very quickly start to pick up on a lot of these patterns. It's like so virtually everything else in mathematics. Again, it's all a big giant pattern. If we can see the pattern, then we can be successful. So again, a lot of optional work here, including going back and rewatching these videos, or if you weren't in class, I guess watching them for the first time. But again, please make sure that you're taking advantage of all these opportunities that that we have in front of us. All right, so again, come see me if you're struggling with any of this, and like I said, we'll get you through.